Introducing RFID Door Lock, a cutting-edge solution that seamlessly integrates heightened security with user-friendly access control. At the core of these locks is the unique code embedded in each RFID tag, exclusively registered to our specialized circuit. This circuit, meticulously organized to recognize only authorized cards, ensures a secure and efficient access control system. By presenting their RFID tags to the door lock reader, users activate this personalized code, eliminating the reliance on traditional keys and mitigating security concerns associated with key duplication or loss. Flexible access permission management further enhances the adaptability of RFID door locks, making them ideal for business, hotels, and residences seeking a modern, efficient, and foolproof approach to secure entry. Building on the foundation of RFID door lock, which rely on unique codes registered to our specialized circuit for secure access. The next step involves assembling the essential components. To create the advanced security solution, we'll begin by gathering the necessary materials: a solenoid lock, an RFID module, buzzer, and a microcontroller board like Arduino. These components will form the backbone of our RFID door lock, seamlessly blending technology and physical security for an efficient and reliable access control system. The solenoid lock serves as the mechanical locking mechanism in RFID door lock system. Operated by an electromagnetic solenoid, this component controls the physical access to a door. When activated, the solenoid extends or retracts a bolt, either locking or unlocking the door. Its precision and reliability make it a crucial element in providing robust physical security. The relay module is linked to the solenoid door lock, functioning as the intermediary that manages the power flow for secure and controlled access. Acting as a crucial connection, it ensures the seamless operation of the solenoid door lock within our circuit. The RFID module is responsible for reading the unique codes embedded in RFID tags. When an unauthorized RFID card or key fob is presented to the RFID module, activates the communication process. The RFID module interprets the data from the RFID tag, verifying its authenticity against the registered codes in the system. The seamless interaction enables secure and keyless access for individuals with authorized RFID credentials. Acting as the brain of the circuit, the microcontroller board or Arduino coordinates the entire operation of the RFID door lock system. It receives signals from the RFID module, processes the data, and makes decisions based on the programmed logic. The microcontroller is responsible for managing access permission, coordinating the activation of solenoid lock, and ensuring the overall functionality and security of the system. Its programmability allows for flexibility in adapting the RFID door lock to specific security requirements. The buzzer in the circuit serves as an audible feedback component. Its primary function is to provide a distinct sound when RFID door lock system grants or denies access. When a user presents an authorized RFID card or key fob, and the system successfully verifies and matches the code, the buzzer emits a reassuring buzz, signaling approval for access. Conversely, if the presented RFID tag is not recognized or does not match the stored code, the buzzer will emit a different sound. Now, moving to the practical implementation, we'll wire the circuit by connecting the solenoid lock, RFID module, buzzer, and microcontroller board or Arduino as per the schematic diagram we've created. This visual guide ensures a straightforward process, allowing you to easily follow along and screenshot the diagram as we display it on the screen. This step marks the transition from theory to hands-on creation as we bring the RFID door lock system to life. Once the circuit is wired, the next step is uploading the code to the microcontroller. This process involves transferring the program instructions to the microcontroller board or Arduino, enabling it to execute the desired functions for the RFID door lock system. After uploading the code, we open the serial monitor and scan the RFID tag or key fob that we want to authorize. Upon scanning, the unique code is displayed, which we copy and paste into the code. This process customizes the system to recognize and grant access to the specific RFID tag, ensuring secure and personalized authentication for authorized users. Following the customization of the code, we proceed to uploading the modified version to the microcontroller. This step ensures that the RFID door lock system is now tailored to recognize and authenticate the specific RFID tag, completing the configuration for secure and personalized access control. Upon completion of the entire process, the RFID door lock system stands as a seamless fusion of technology and security. With the solenoid lock serving as the robust guardian of physical access, the RFID module reads and interprets the unique codes embedded in authorized RFID tags. The microcontroller, functioning as the intelligent core, orchestrates the entire operation. As a user presents their RFID card or key fob, the system checks the scanned code against the customized code stored in the modified code base. If a match is found, the solenoid lock is triggered to either extend or retract, allowing or denying access accordingly. This final output is a sophisticated and reliable access control mechanism that not only ensures heightened security but also offers a user-friendly and keyless experience. The system, now finely tuned and personalized, reflects the culmination of precise wiring code, customization, and successful integration, embodying the potential of RFID technology and modern security applications.